Hello, everyone. My name is Paul Minter, and I am a current PhD student at the University of Cambridge, working with Nishan Wickramasinghe on various problems in the regularity theory of stationary integral varifolds or minimal surfaces. So in this talk, I wanted to discuss a recent work of mine, which proves a sort of a C1 alpha regularity result in a certain setting for stable codimension 1 integral varifolds. So as a bit of background, one of the main difficulties in understanding the singular set for stationary integral varifolds is when if we produce a tangent cone at a singular point, if there's higher multiplicity in that tangent cone on its regular part. This can occur. And for example, high multiplicity planes is a particular instance where this happens. And such points correspond to what we call as branch point singularities, essentially. So in the most basic case of a multiplicity 2 tangent plane, Nishan was able to establish under a mild topological assumption that for a stable codimension 1 integral varifold, if it's close to a multiplicity 2 plane in the sense of varifolds, then in fact we have a suitable multi-valued sheeting theorem, which is rather similar to Allard's original regularity theory for a multiplicity 1 plane. So the next case of interest is not a plane, but it's a density 5/2, or 5 halves cone, which is formed of a union of 5 half hyperplanes meeting along a common axis. This is what I call a classical cone of density 5 halves. So we would like to understand the structure of stable codimension 1 integral varifolds near such a cone. Now, the thing is that with 5 half hyperplanes, it's possible to have overlap for 2 of the half hyperplanes and have multiplicity 2 half hyperplanes occurring. So therefore, branching behavior in the varifolds nearby is very much a possibility, and this severely complicates the analysis which we have available. So in this talk, I wanted to discuss several, illustrate the difficulties with several examples and talk about how we're able to prove the regularity result via using several different blow-up procedures. So there's a coarse blow-up procedure, there's a fine blow-up procedure, and then there's a further ultra-fine blow-up procedure which is needed to establish regularity of various classes of functions, which we then use to establish the regularity of theory for the varifolds. So thank you very much for listening, and I hope you'll come and listen to my talk. Other than that, thank you very much.